Would you believe that an organism as small as a grain of sand could tell us what the climate was like 100,000 years ago? Nuh-uh. No, really. These are foraminifera, or forams for short, and their fossils tell us about climate history. Climate history is like a puzzle. You have all these complicated pieces, but you can't see the big picture until you put them together. Forams are one of those pieces. Forams are microorganisms that build their shell from dissolved carbon and bits of other elements in the ocean. By using known relationships between the bits in the foram shells and characteristics of the ocean, we can use fossilized foram shells to reconstruct past ocean chemistry. The ocean helps regulate global climate. One way it does this is by absorbing atmospheric carbon dioxide, or CO2. The amount of CO2 in the ocean affects many different substances, one of which is called carbonate ion. In my thesis, I reconstructed carbonate ion across two climate transitions in the Eastern Equatorial Pacific, or the EEP, which releases more CO2 to the atmosphere today than any other region of the ocean. Because CO2 and carbonate ion are linked, reconstructing carbonate ion gives me an idea as to whether or not the EEP was absorbing or releasing CO2 in the past. I first looked at 25,000 years ago to today, when the Earth went from an ice age into the current warm period. Then I looked at 96 to 60,000 years ago, when the Earth went from the warm period into an ice age. To do this, I ordered sediment collected in the EEP, rinsed away the mud from the fossils, spent hundreds of hours on a microscope picking out thousands of fossils one by one, cleaned them with chemicals that could literally explode if I had done it wrong, and blasted them with temperatures hotter than the sun to analyze their shells. Yeah, it wasn't easy. My results indicated that across both climate changes, the EEP released as much or more CO2 than today, apart from a few brief time periods between 25 and 13,000 years ago. This suggests the Eastern Equatorial Pacific may continue to release CO2 in the future. Now, I know I reconstructed ocean chemistry in one small region of the ocean, across two small time periods, with thousands of small organisms. But in order to see the big picture in the puzzle that is climate history, every piece counts. Thank you.